All right, so today we're just doing a lot of operations with vectors. So we have, for example, we have two vectors. I have vector V and I have vector W. What do you think this is telling me to do? I'm just gonna ask you, what do you think? That -5 vector W, what is it asking me to do there? Multiply. Because we know that if you put a number next to anything without any separation, that is multiplication. So what all question A is asking me to do is multiply vector W by -5. That's it. So I'm going to take this vector and I'm multiplying the horizontal and vertical components by -5. So you're distributing, even though that's not a parentheses, that's a vector bracket, we're still distributing into that vector bracket. So my final answer would just be -15, +20. So we keep it in our vector form, yes. One more time. For A, nothing. Because question A only asks you to use vector W. But did I do it wrong in my notes? Okay. Yeah, so vector A, or question A is only asking you to use vector W. Now question B wants you to use both. What question B is saying is multiply vector W by 4. And then we're going to subtract from that vector V. So B uses both vectors. So we're going to distribute. So that would become 12, -16. And then what I like to do whenever it's subtraction is distribute a negative and change it to addition. So I'm going to change this to addition and multiply -1 times 6 and -1 times 6 and -1 times -6. So now the last step I'm going to do is add together my component. Remember, the first one is your horizontal. So we're going to add these together. And your second one is your vertical. We're going to add those together. When you're finished doing your operation, you should just have one horizontal component and one vertical component. So my final answer would be 6, -10. That is it. Any questions? I think that 9-4 is very simple. All right, now let's look at example 2. We have two new vectors. Now we have vector V, which has a horizontal component of 4 and a vertical component of -1. And vector W has a horizontal component of -3 and a vertical component of 5. So what I'm going to do is I'm going to take vector V and I'm multiplying it by 3. And then plus 2 times vector W. So you're going to distribute, and then add. I'm going to give you a couple minutes to try to do it on your own. I'm going to freeze my screen. Then I'll put up the answer shortly. So we have to distribute first, and then we have to add. Who has the answer for A? Would anybody want to volunteer what they got? Jaden?
6.
Oh, well, it's okay. No.
You got it. You got it.
Yeah.
No, you got it. I got it. 6, 7.
All right, that's what I got too. All right, now let's do question B. This is all we got. This is all we're doing is operations with vectors. Question B is saying take vector V and multiply it by 2. And then take vector V again, okay, and multiply that by -5. So let's look at this a little closer though. There's nothing wrong with doing it this way, but because we have the same vector, could we have combined those like terms? Yeah, so we could do it this way, or we can combine that, because what if I asked you what 2v minus 5v was, what would you say? What's 2v minus 5v? -3. So you can also just multiply v by -3. So I've given you 3 different options. Go ahead, choose one to get your answer. Yep, either one. All right, now let's go to the next page. We have 3 different vectors, but we're still doing the same operations. Now I have vector F, vector G, and vector H. So these are different vectors, so I can't combine them. I have to do them separately. So I'm going to take vector F and multiply that by 3. Then I'm going to take vector G and multiply it by -2. I would multiply it by -2 and change it to addition. I'm going to give you 60 seconds. Come up with your answer. Okay. I think I did this wrong in 5th period. Oh, I know what I did. Okay, in 5th period, I didn't change it to addition. All right, what do you get? What is 21 plus? So this is what I got after I multiplied. I multiplied the second vector by -2 and changed it to addition. So 21 plus 16 is 37. And what's -3 plus 16? 13. All right, let's set up B. B is using all 3. So we have vector F, which is not changing. We're adding to that 3 times vector G. And I'm adding to that 5 times vector H. When you're finished, you should only have 1 horizontal component and 1 vertical component. So I'm going to give you a moment. Distribute, combine your like terms, and you're done.
not an easier way to do this.
Hmm?
There's not an easier way to do this.
So what's different about this one? Do we have any like terms? So David, this is important. I want to make sure you understand. If you go back and look at the example, so go to page 3, look at example B. Why did I combine that? Because that was the same vector. You see how it said 2v minus 5v? It was the same vector. That's why we combined it. If it's not the same, that means they're not like terms. We can't add them. Because we only have one more test, I just want to make sure that we're good. So, double check my answer though. Because I don't know why. I feel like that it's not right. So I'm going to see. Did you all get that answer?
Yes.
Okay. All right, go ahead and do C all by yourself. I'll put up the answer shortly. Using all three again. This time they're in different order. So we got H first, then we have F, and then we have G. So pay attention to that. All right, who got 6244? All right, this next piece is just information. It's a new definition. When you scale a vector, that means that you're changing the magnitude without changing the direction. So that's what we did in all of the examples before. Whenever you're multiplying a vector, I'm changing the magnitude. So when we do our formula, remember the formula for magnitude is delta x squared plus delta y squared under a square root. So the magnitude is changing, but the direction, when you take the inverse tangent of y over x, will be the same. So for this last one here, I'm multiplying it by 2. So I'm going to take 2 times vector v. And my final answer would just be 10, negative 12. So the last thing we're going to talk about, and we'll be finished for today, is how do you determine if a point is on the vector? After today, you will be able to finish all of homework 17 in its entirety. So we will have everything covered and you can finish it and be done. So you all have a things to know box. Does everybody see that things to know box? So this is a formula. Ding, ding, ding. It's another formula. How do you write a set of equations? So we're going to write a set of parametric equations.
Where do I write this? Inside that box?
And you don't have to write all this down, but this is in that things to know box. So delta S, the formula, not delta S, x of S x of s is equal to x1 plus the change in x. Y of s is equal to y1 plus the change in y. So the first thing you're going to do when we look at this example, we have vector v, which starts at 1, 2. So that means that this is my x1 and my y1. Your start is your x1, y1. We have the change in x and we have the change in y. So x of s is going to equal 1 plus 3s. That's how we're going to write that equation. So we're going to put an S after this. So you're going to take the change in x multiplied by s and the change in y multiplied by s. So that would be my first equation. What would be my second equation for y?
2 plus 5s.
That's it. So for part A, there's an infinite number of answers. We just need to choose a random number for S. So Clinton, give me a number. Any number. 6. So let's figure out, in order to find a point, we're going to substitute 6 into both equations. So if S equals 6, let's write our ordered pair. That means that X would be 1 plus 3 times 6. And your Y value would be 2 plus 5 times 6. When you do this on your homework, you should all have different numbers because nobody's thinking of the exact same two numbers. So let's go ahead and figure out what we get. Substitute this in your calculator to find your X value. And then you're substituting this in your calculator to get your Y value. So using the S value that Clinton provided, another point that would be on the path of this vector would be 1932. That's an ordered pair that's going to fall on the path of this vector. All right, I got to erase some stuff because my pen writes kind of big. All right, Sanaya, give me another number, any number. 3. All right, so let's say S equals 3. I want you to do it again. Give me the ordered pair that you would have if S was equal to 3. So I just gave you 2 points. Those are just 2 random points. And it doesn't matter what number you choose. Wait, who got 10, 12? All right, so I plugged in the number, the S value that Clinton gave. He gave me 3. When I substituted it in, I got the X would be 10.
Wait,
and
how did you get 17?
Oh, that's why I was saying, did y'all get that? Something felt wrong. So now do we agree that it's 17? We agree now? Okay. So when I plug in the 3, I get that X is 10 and Y would be 17. So that's another point. Now, when you're picking your S value on the test, you can pick any number. It could be a positive number. It could be a negative number. It could be a huge number. It could be a decimal. It does not matter. You pick any S value you want and you substitute it in. Yes.
Could it be 1?
It could be 1. Could be 0.
If it's 0, the answer is 0.
No, it wouldn't be 0. It would be 1, 2. You'll be back
Oh, yeah,
at the
right.
start. You just you're giving me the starting point. So maybe not 0, because it does say on the path, and 1, 2 would be the start of the path. So, but you could put in 0.1, 0.000001. All right, last thing. How do we figure out if we're given a point if it's on the path? So we're simply going to substitute the values we have in our set of equations. So I'm going to substitute 7 in here. So let's set that equal. So we have 7 equals 1 plus 3s. Make sure your s doesn't look like a 5. And then the y value on that point is -8. I'm going to put that here. So -8 equals 2 plus 5s. I want you to solve both of those equations for s. Solve both for s.
Are we choosing anyone?
No, you got to solve it. You see that equation? 7 equals 1 plus 3s. Solve that for s. So we have to figure out what s is. I know you all haven't had to solve an easy equation in a while. It's probably like, how do you do this? All right. When you solve it, who got +2 and -2? So that would be a no. The only way we could say yes is if we get the same number. These two numbers have to be the same. So because these are different, the answer is no. 7, -8 is not on the path. If you got the same value for s, then it would be yes. All right, any questions? All right, you take out homework 17, y'all. Let's get to work. Let's try to finish it out.